Hi again, and once again I start my day from LeetCode, and that would be the seventh day. Let's see what do we have today here. Medium task, alternating group 2. Well, there is a circle of red and blue tiles. You are given an array of integers, colors, and an integer k. The color of the tile I is represented by colors I. Colors I is 0 means that I is red. 1 means that tile is blue. An alternating group is every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and last one has a different color from the left and right tiles. An alternating group is every k contiguous tiles in the circle with alternating colors. Each tile in the group except the first and last one has a different color from its left and right tiles. Return the number of alternating groups. Note that since colors represents a circle, the first and the last tiles are considered to be next to each other. Okay, colors. K is 3. Output 3. Ah. One, two. One, two, 3. Okay, got it. Here we have 1, 2, 6. 1, 2, 3, 4, 5, 6, 2. Yes. Well, interesting task. Colors length could be really big, but starting from 3. Okay. Every color is either red or blue, and k less or equal to colors length, and of course there could be 0 as an output. Okay. How can we solve it? We should keep in mind two things. First thing, we should count the number of alternating tiles, the number of alternating tiles, and one more important thing is that Alisa, stop. Sorry, give me 1 minute. What is also important, we should loop this algorithm. We should close it. We should close the loop. So we don't only have to check that there are alternations between first and second. We should close it. We should like move through it and little and k elements more. So how I will do it? Make a loop from 0 to colors length plus k after the end count from the beginning. Well, count number of alternations of consequent alternations. Is the word alternations? Alterations. When the consequence of alterations is when the consequence of alterations is, how to say it, interrupted, or the loop is finished. We write number of consequent alterations minus k to the result. Not right, we add. Okay, let's try. For let equal to 0, index I less than colors length plus k I plus plus. Yes. If I const past tile index equal to I minus k. If past tile index less than 0, then we will continue. We need additional variable number of consequent alterations. 0 in the beginning. Consequent alterations. Yes. Const current tile is colors I get the reminder of the division from I to colors length. Color index is this, current tile is this, and previous tile is if I less than 1, continue. Current tile is colors color index, and here -1. If they are equal, then we will increment number of consequent alterations. If not, we should reset it. Okay, now we can count it. Now we can count it. Yes, it should work. And I want to create one more variable where I will put the result, which is initially 0, but if number of consequent alteration is bigger or equal to k, then we will increment the result, and in the end we will return it. Okay, yes, it should work. Yes, so now we have a loop. We have comparison of the values. We can reset the number of consequent alteration. We can also put the result, increment the result. I should make sure that the number of color index also. Let's imagine that we have this array length of 5. When we will have index I colors length plus k. K is 3. So 5 plus 3 is 8. So last index would be 8 less than 8, 7. Last I would be 7. 7. The remainder from the division of 7 to 5 is 2. So the last color index would be 2. This one. Is it okay or not? So K would be 3. For example, I is 0. Here, I 1. We are here. We're comparing this and this. And consequent alternation would be 1. Then I2, we're comparing this. Consequent alternation would be 2. After that, I3, consequent alternation would be 3. And here we are writing the first result. And this is okay. 3 result would be 1. Then 4 result would be 2. Then 0 and 0. Here we have a problem, because we should increment result when we have more than 2 consequent alternations, because we were alterations, because when we have 2 consequent alterations, we have actually 3 altering colors. So K minus 1, and here we will have 1, 2, 3. After that, we will we will reset number of consequent alteration. After that, it will again become 1. And I think here we should finish our loop. We don't have to compare these 2 elements, because we already did it in the beginning. In other case, we will add one more point to the result. So the result would be 3. 1, 2, 3. That's it. We will return it. Past index. We don't need it because we have a remainder. Well, let me check how to translate it correctly. Remainder from division. Remainder of 2 divided by 4. Okay, remainder from division or remainder of we have a remainder of I divided by color's length. Here we actually can start from 1. Or we can start from 0 and compare previous and next. Well, I think it doesn't matter. Let's make one more check. So here we will have 1, 2, 0, 1, 2, 3, 4, 5, 6. Wow. One, 2, 0, 1, 2, 3, 4, 5, 6. Why 2? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. 5 and 6. Yes, it will work. So here is 1, 2, 3, 4. Sorry. One alteration, first alteration, second alteration, third alteration, fourth alteration, fifth alterations, and here we will increment the result, and sixth alteration, here we again increment the result, and it would be what we're looking for. It would be output 2. And the last I would be I minus k, which means that we should color's length plus k. 1, 2, 3, 4, 5, 6, 7 plus k 6, 13 minus 2, 11. Remainder of 11 divided by 7 would be 4. 0, 1, 2, 3, 4. Yes, and we will finish here. Okay, looks good. Let's try. My favorite mistake. Output 0, expected 3. Strange. There are no right answer. So let's check. Colors. 0, 1, 0, 1, 0. We're starting from I1 and we'll end by I5 plus 3, 8 minus 1, Okay. 5 plus 3 minus 1 would be 7. So I would be from 1 to 6. Past tile index. I don't use this variable. Color index would be 1. Current tile, first one, and previous tile 0. Yes, the condition is wrong. If they're not equal, then we should increment. Well, and again we have a problem. If color is not equal to previous tile, we will increment number of alternations. It will be incremented. Number of alternations would be 1. After that, next loop I would be 2. Color index would be 2. Current tile would be 0. Previous tile would be 1. They are not equal. We're incrementing number of consequent alternations. It would be 2. And here we will have the first increment of result. Because k minus 1, k is 3, is 2. It is equal to 2, which is fair enough. This is the first alternating group. Yes. So the result, number of alternations would be 2, result would be 1, and we're going to the next loop. 3, I3, we're comparing these numbers. Number of consequent alternation would be 3, result would be 2. That's it. After that, I would be 4. Last one. We're comparing these two numbers. Number of consequent alternations is incrementing 4. Result is incrementing 3. That's it. After that, we are having wow, yeah, now I got my mistake. Now we're having number 5. Oh, sorry, not here. Here, I is 5. Color index would be 5. Remainder of 5 divided by 5. It would be 0. Here we will have element of number 0, which would be 0. And here we will have element of index 0, -1. Color index and previous color index I -1. Here is the problem, I believe. Because we had undefined is not equal, we are incrementing it, after that it is not equal again, and we will have 5 elements in a row. Well, I will remove everything to make it simpler. Okay, let's check. Yes, now it works. Let's try to simplify it a little bit, as I wanted to do before. I wanted to start calculating I from 0. Here I remove 2. Last index is -3. Last index minus or equal to last index. Well, how does it work? Sorry. That could be one more big mistake. It's strange it works, because we're not getting an index here. We're getting colors. Well, why does it work at all? It was working because of, I don't know, because of strange mistake. Colors, yes. Just randomly, I believe. Okay. 0 -2 I plus color index I +1 previous color index I. Nothing should be changed here. Yes, now we can remain it. It would be next color index, and that would be current color index. Current color index, next color index, current tile, and next tile. Current color index, yes. Pum, pum, Boom, 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 boom. Let's simplify it a little bit more. Last index should be this minus or equal to last index. Here we're getting colors. K minus 1. What else can we simplify here? If they're equal, we can make an early exit. And we should not increment it every time. But this is not a bad idea, actually. Okay, let's try to submit. I don't know what to improve here. More. I think it's just as simple as possible. Okay, let's do it. Yes, it works, but this is not the best solution possible. It beats only 50% of solutions. Let's look at the best ones. What kind of optimizations do we have here? Oh, we modify the colors array to push colors from the beginning. After that, we're just doing the same trick as I did. And that's it. Well, okay, looks good. Well, where is my solution? Accepted. This one, code sample, code, yes. Let's calculate the complexity in terms of memory. It would be we already have colors, but we don't have to keep anything in memory, some additional values or arrays. So it would be big O of 1 and CPU would be big O of n big O of colors length plus k. So it would be big O of n. It's 100% right now after adding some comments. Time complexity, space complexity. Okay, yes. This space complexity is more correct. Time complexity, not CPU complexity, space complexity, not memory complexity. Okay guys, we did it today. Thank you very much.